All right, so today in this block, this is Agile Mind Section 3, Block 5. We're going to decide whether two quantities are in a proportional relationship by looking at a table or graph. We're going to identify the constant of proportionality or unit rate in tables and graphs. We're going to be able to represent non-proportional relationships with equations. We're going to be able to explain what a point, x, and y on the graph of a proportional relationship means. And we're going to be able to solve word problems leading to equations in the form of px plus q equals r. All right, so I want us to think about two scenarios. I want us to think of a scenario that is proportional, and I want us to think of a scenario that is non proportional. And I want us to try to figure out if we can tell from the description of a scenario whether or not it is proportional. All right, so when I say a description, basically I want you to think up of a description, and the entire class is going to try to decide whether or not you're talking about a proportional relationship or a non-proportional relationship. Okay, so I want to give you about, we'll say, a minute to think up of an idea that is a scenario that is proportional and a scenario that is non-proportional. Okay,
Basically your own sentence.
yeah.
Can we use the pizza question? Can we just
Well, you could do something similar to that. What I'm going to do is I'm going to allow y'all to break out into groups for, I'm going to give you about 40 seconds to come up with an idea. I want you to memorize your group. I don't want you goofing off. All right. So make sure that you're doing what you're supposed to. I'm going to put 30 seconds on the clock. Make sure you come up with something. Okay. Rooms are open now. Group, Halen, what did y'all come up with for a proportional description?
We said every piece of cake is 150.
All right, so every piece of cake that you get costs $1.50. All right, what's the other one y'all came up with?
We didn't.
Okay, so I want y'all to think about the one that they said. If each piece of cake costs $1.50, would that be a proportional or non-proportional?
Can we answer if we were in her group or not?
No, don't answer if you're in a group. You can restate what she said, though, Jacaden. Restate it.
I answered the question. She just wrote it down.
Well, that's why I said restate it.
I said every piece of cake from the cake factory is $1.50.
Okay, so is that proportional or non-proportional, class?
Non-proportional. I mean proportional. It would be non-proportional if I said every piece of cake was $1.50 plus 25 cents per top. Yeah.
All right, listen to what Jacaden just said. He said the original one is proportional because every piece of cake was $1.50. Okay? But he said to make it non-proportional, what, Jacaden?
It would be 25 cents per topping because you get one cake that's original and one cake with like two toppings. The price would be different.
Good shot. Good shot. All right. Our next group was Miss Emma. Emma, give us one of yours, and we're going to see if we can pick if it's proportional or non-proportional.
I think that one because we started talking and then the group was like, who knows me?
You said you didn't get to it?
No.
That's not cool. All right. What about Chandler's group? Chandler Thomas's group.
Yeah, I'll take over from here.
Okay, go ahead, Isamian.
So y'all gonna have to guess which one's a proportional or non-proportional.
That's the goal.
Okay. For every 2 minutes, I'm trying to remember the name that we gave her. For every 2 minutes, Karen drove 10 feet. So it's basically 2 minutes she drove in 10 feet.
Okay. Do y'all think that's a proportional or non-proportional statement? Come on, people. You ought to be able to get this pretty quick. Izamian said every 2 minutes this person drives 10 feet.
But here's the thing. I started off with the second base number. I didn't start off with the first base. What? Because in a chart, you have two different sides, which is one side telling you X and the other side telling you Y. And there's different categories on those charts. I only used the second base. I didn't use the first one.
Yeah, but if in 2 minutes she can drive 10 feet and the rate stays the same, does the rate stay the same, Izamian?
Not really.
All right. Well, so he's saying that her speed varies. Okay. So you got to give us a little bit more detail, Izamian.
Okay. I'm gonna go ahead and give y'all the first definition. In 0 minutes, she drove 4 feet.
Okay.
And after that, 2 minutes, she drove 10 feet.
Okay.
After that, 4 minutes, she drove 16 feet. And then 6 minutes, she drove 22 feet.
All right. So, based on the information that Izamian gave us, would this be a proportional or non-proportional statement? Good job, Militon. Non-proportional. Why, Militon?
Because they are not the same.
All right, good shot. There's no constant rate. Good deal.
Also,
All right.
He's right. There's also some other way how you can figure that out.
How, Izamian?
Because if you take 210 and then 622, and then you divide them by 2, right?
Mm-hmm.
For 2 tens, you get 1/5, but for 622, you only get 3/11.
I got you. So, just like Milton said, Izamian was telling us if we tried to find the constant rate by using division, there's not a constant. All right. The next group was, let me see your names. Joel. Joel, what about your group?
We didn't even speak.
What?
They weren't even speaking. I unmuted my mic, but no one was gonna speak.
Man.
Because I just joined this class, so I didn't really know what y'all were talking about.
All right. So, in other words, you're telling me that I should tell your group that they all got a 0 today.
Okay.
No, I'm kidding. Y'all need to speak up. Tashandrick said he's trying to help you right now. Tashandrick, go ahead.
For every 2 bags of chips, they cost $2.
This one I got a 0.
All right. Did y'all hear what Tashandrick said?
Excuse me. No, because someone interrupted.
Go ahead, Tashandrick. Talk loud.
For every 2 bags of chips, they cost $2.
Okay. Would that be proportional or non-proportional?
Yes, sir. Proportional.
Why?
Proportional because it's a constant rate between.
What is the constant rate? How much would one bag of chips cost?
$1.
Great job. Great job. All right. And our last team was Miss Haley S.'s team. You're good, Jamal.
We did. If you go to the get ice cream, the cost for ice cream is $2. But if you want to put sprinkles or something on there, it's going to have to cost an extra 75 cents.
Okay. So would that statement be proportional or non-proportional, class?
Non-proportional.
Why?
Because there's not a constant rate.
Good shot. Is that what y'all said, Haley? All right. So I just want to say, Militon, you're doing an excellent job because you're the one and basically only person that kind of pulled every one of those scenarios and said whether they were proportional or not proportional. I want everybody to kind of focus on what Militon did, and that's how I want y'all to interact today, okay? Good job, Militon. All right. let's check out. Let's see what else we can find. So let me get this light flipped on. Let's look at page 1. Read what page 1 says for us, please. Let's see who this is. Haley, go ahead and read it for us.
A landscaper is installing a square pond. The pond will be 4 feet long and 4 feet wide. She wants to surround the pond with tiles. She wants to know how many tiles she will need. Without counting each individual tile, how can you determine the number of tiles the landscaper needs? Try to come up with more than one way to find the number of tiles.
All right, thank you, ma'am. So, they don't want us to count each individual tile. So, how can we determine the number of tiles the landscaper needs? And they want us to try to come up with more than one way to find the number of tiles. So, it's saying that the pond is going to be 4 feet long and 4 feet wide. Okay? But she wants to surround the pond with tiles. So she wants to know how many tiles they need. So I want you to think about how we could do that.
Like, does she want to make it like? Does she want like?
She wants to be able to fill in where that fish is.
So it's basically length times width.
All right. He said maybe length times width. So that would be how many tiles? If it's 4 feet long and it's 4 feet wide, how many tiles would that be?
Well, length times width where time means. So 4 times 4. My brain just went slow for a second.
You're good. At least it's trying.
What was the question you said? I'm sorry.
Good job, Jashandra. He said 16. All right. But that's only going to be the length and the width. Is it going to cover the corners? No, it wouldn't. So how would we know what to do for the corners?
You don't do nothing for the corners, huh? Area?
Well, if you don't have the corners filled in, wouldn't the water leak out?
Yeah. So you must have to need 7. No, not 7 tiles. 17 tiles. So
All right. 17 would be one corner and the length and the width of every one. So I'm gonna draw something. I'm gonna show you what Isamian was thinking. If we did the length times the width, that would be the width. This would be the length. That would be the width. And that would be the length. So right now we only have these tiles with 16. So the water is going to spew out right here, right here, and right here, and right here. So what do we need to have?
That's why my brain stopped.
How many more do we need than what Isamian said?
We need like 4 more.
Yeah, we need 4 more.
Listen, because you know it got the cracks in it. If the cracks weren't cracked, it would not leak.
You are true. Yeah, that is true, Jacaden. That is true. They had to use some stop leak or something. Some of that spray in stuff. I'm just kidding. Like the commercial that where they float the boat. Yeah, that flex tape. All right. So looking at this, what is a equation we could come up with or an algebraic rule that would allow us to find this?
Four times 4 times 4.
4 times 4 times 4 would be 16 times 4.
You said in algebraical,
Yeah.
like with the y and x.
Well, you could, or like, in other words, like what equation would give us the answer? Like, what are we dealing with? The only two things we're dealing with is this and this.
I feel like it still has to do something with link times with.
It does. I agree.
Link time, his time, height.
Well, that would give us the volume. So let's see what they did. All right, read what it says to do there, Laney, so we'll know what to do. Right here in the gray, light gray.
Drag the tiles or strips of tiles to the pond to show different ways you can count the tiles around the pond. For each possible way of counting the tile, record a number sentence to represent that counting strategy.
All right. So everything that we do, we're going to use this as recording this. So we're going to record this on question 1, okay, in the workbook. So what do y'all want me to go with? How many? Y'all want me to use this or this? Just name the color.
Blue. Okay, for the sides, go with blue.
All right, so we're going to use the blue one. And am I going to use that at the top or the sides?
Sides.
All right, so that would be 2 times what?
2 times
6.
All right.
And then use 4 for the sides.
So,
Which is the green.
so that'd be plus 2 times what?
4.
All right. So that's one number sentence. What? All right, so let's see what it says. Record a number sentence that corresponds with your counting strategy, then try to find and represent. So we said 2 times 6 plus 2 times 4. 2 times 6 is 12. Plus 8 is
20.
20. Good. 20. All right. So that works. All right. So remember, that's going to give us our 20 tiles. So we're looking for ways we can get 20 tiles from this using these. Okay. So that's our first number sentence. So if you don't have this number sentence written down, you need to write it down now. Okay. All right. Let's clear it and see if we can come up with another way. What's another way we could do it?
Use 2 3 blocks for the sides.
The orange.
So that'd be 4 times 3.
Yes. And then use 2 yellow blocks for the yeah.
I'm supposed to be adding, right?
Yes, sir.
Well, that didn't flip. And so this would be 2 times what?
2 times 2.
No, that ain't 2. How many yellow blocks did we use?
4.
Why are you not flipping? Yeah, there we go. 4 times how much?
4, 2.
Good. And is that going to equal 20?
What times 3? 12. Yeah.
Yeah, because that's 8 plus 12, right? All right, so far we got 2 of them. right. Let's see if we can get another one.
Oh, let's see. Can I go or?
Yeah.
All right. Use one green block. No, bring it up. Stop trying to play sneaky. And then get one yellow block. And then do the same thing to the other side. And then no. I was gonna say use one orange block and then one red block.
Oh, well, that works. So this is 1, 2, 3, 4 greens and 2 yellows. So that would be 4 times 4 plus 2 times 2. All right, so I want y'all to think about something. Could we come up with the equation 4 times the sides plus 4 for the corners?
You say could we get the same number or could we?
Would that work? Could we do
Yeah.
4 times the sides plus 4 for the corners?
Yes, because that's what we're doing anyway.
Well, let's check it. Oh, that kind of matches the fish tank and the fish color. All right, so we got 4 different ways right now, right?
Mm-hmm.
All right, do y'all have these written down? Haley, do you have them written down? All right, Haley got them written down. What about you, Halen? All right, I'm trusting that everybody's got it done. So let's see if ours match theirs. Oh, goodness. Read what that says. Militant. I can't hear you, Militant.
You're muted.
What if the landscaper decided to make a pond with different dimensions? Draw the square pond with the different size length. Determine the number of tiles needed to surround each pond. What is the relationship between the side lengths of the pond and what number of tiles? Create a table, a graph, and a algebraic rule to represent the relationship between the side lengths of a pond and number of tiles used. The represent the side length and R to represent the number of tiles.
All right. S represents the side length. T represents the number of tiles. So what are we trying to find?
The number of tiles.
Good. So that means that T is going to equal something. How many sides do we have?
4.
Okay, so T would equal 4 times the number, or 4 times however many sides we have, plus we said how many what?
Oh no.
We talked about it earlier. Wasn't it some corners or something?
Yes.
Yeah, so how many corners are there?
4.
Yeah, there's 4 corners. So that would be tiles equals 4 times the sides plus our corners, which is 4. Can we take this equation and write it a different way?
Probably.
Okay, let's think of what we could do. I want you to think about the distributive property. Remember, the distributive property is when we take a number and we multiply what's inside the parentheses. So, what if we said, what's something we could do?
We had 6 sides, if I remember correctly. So 6, what's 6 or 5?
Somebody help him out.
Are you talking about the first? We had 6 sides and.
I thought we've only had 4 sides this whole time. Now, we had a lot of blocks.
Oh, but we only have 4.
So think about, like, what could you break this down into? What times 4 equals 4? I mean, or what times something equals 4?
2.
Okay. So could we say T equals 2 times 2S plus 2?
Because 2S stands for 2 sides.
Correct. So what's 2 times 2S?
4.
4S. What's 2 times 2?
It's 4.
So does that work?
Yes, sir.
All right. Could we say T equals 4 times S plus 1? What's 4 times S?
4 times S. Because S is.
Wouldn't 4 times S be 4S?
Yes.
Okay. What's 4 times 1?
4 times 1.
Yeah. So wouldn't that be the same as the one at the top?
Yes, sir.
Yeah. We obviously missed something.
Yes, we did.
I'm going back to 3. Oh, that's annoying. It said create a table, a graph, and an algebraic rule to represent the number of tiles. Well, we came up with the algebraic rule. So think about a table. So we got to try to think of a table and how it would work. So first thing we're going to do is look at a graph. Okay. So it says your graph should look something similar to this. Is the relationship proportional? Yes or no? Is it proportional?
No.
No. Why?
It's not on origin.
That's right. Good job, Faith. It's not going through the origin. All right. Since it's not going through the origin, it's not proportional. Why is it not going through the origin?
I'm guessing because it's non-proportional.
Well, yeah, I mean, that's a good answer. But correct, it's not going through 0, 0. But where is it passing through? What number?
4.
4. Because of what? It's 4 of them, and they're on the outside. What? Starts with a C.
I really just had this word in my mind. Corners.
Thank you. The corners.
Oh.
Who was that? Layla?
Oh, but do we need to draw that?
All right. So it says if the relationship is proportional, what is the constant? Well, it's not proportional. Just like Faye said, the graph does not pass through the origin. So that line's not passing through there. It says, what does the point 0 to 4 represent? All right, 0 to 4 is representing what? If the side links are 0, don't you still have to have how many corners? How many corners do you have to have? Even if the side links are 0, since we're making a square. Yeah, we got to have 4. So the next one says 1 to 8. So that means that the side length is how long?
You said 1 to 8?
Yeah, the side length would be how long for 1. Look what it's telling you. It's telling you that the side length is here at 1. So the side length would be how many feet?
1 inch.
Not 1 inch, but 1 foot. Good job. So it's going to be 1 foot per side, okay? But then you still have how many corners?
4.
4. So read that for us, please, Mr. Jamal.
The point 0.4 represents a pond of side length 0 needing 4 tiles to surrounding it. This point does not make sense for the scenario. The point 8.1 represents a pond of the side length 1 foot needing 8 tiles to surround it.
All right, so remember our X comes first and our Y comes second.
Last.
So when it says the point 1 to 8, it's talking about the side length is 1 foot per each side. Okay. And then our Y is representing the total number of tiles to surround that. All right. So let's check out number 5. All right. Look at that equation. Would you read all this for us, point?
The equation that response respects the relationship between the side links and pond number tiles is. You want to read all of it?
Why don't you read that equation? T equals what?
4s plus 4.
Good. And keep going.
How can you use this rule to find the number of tiles needed for any side of the pond? For example, how many tiles would you need for a full size length 5?
All right. So if the side length was 5, what would you have to do for this equation? What would happen to the S? Jacaden, what would happen to the S?
It will get bigger.
It would get bigger. All right. How much bigger?
4, huh?
Well, look at what it says. It said its side length is going to be 5.
5.
So that means that S would be equal to what?
5.
Yeah.
It will be equal to 5.
So that means we got to do 4 times 5. And then we got to add what?
S.
Not S, but 4.
4.
So what's 4 times 5?
20.
20. What's 20 plus 4?
24.
All right. So we're going to check our answer and see if that's right. Read what that says, Reginald. We can't hear you, buddy.
My bad. Replace the S with the actual side link and solve for T. If the side link is 5, T equals 4.5 plus 4. So you would need 24 tiles.
Good. So that's saying that 4 times 5 plus 4 is 24. Right? So let's look at that next one. Lainey, will you read that?
How can you use to find the number of tiles needed for any size pond?
Hold up right here.
What if you knew you only had 36 tiles? How could you write an equation to represent the size pond you could tile?
All right, so we know there's a total of 36 tiles. So what could we do?
And divide or multiply and multiplication wise.
Well, if we're using this equation, what could we do since we know there's going to be a total of 36 tiles? Chandler raised his hand. Chandler.
9 times 4.
All right, 9 times 4 is 36. All right. But what should T be? 36 is for what?
Tile.
The tile. So can we say that 36 is equal to 4s plus 4? So I want us to start simplifying this. If I want to get 4s by itself, what can I do with plus 4 to get rid of it? How can I make plus 4 become 0?
Subtract.
Yeah, so if I subtract 4 on one side of the equation, I got to do it to this side. What's 36 minus 4?
32.
Correct.
32.
So 4 minus 4 is 0, and 36 minus 4 is 32. If y'all aren't writing this down, I would write it down really quick, because it's going to get interesting if you've never used this before. All right, the next thing is 32 equals 4 times s. So if I want to get s all by itself, I have to undo multiplication. What would undo multiplication?
Division.
Correct. So I have to divide by 4 on both sides. So dividing by 4 here makes 1. And 1 times s is what? How many s's? Don't if you multiply anything by 1, it's just itself.
Correct.
All right, so I'm left with s. And what is 32 divided by 4?
8.
Good. So that means that our side lengths are how long?
8 equals s.
So how long are the side lengths? How many feet?
8.
8 feet. Good. So write that down, and then we're going to check our work. I still got a lot of people that aren't showing their screens. Man, I really need to be able to give y'all as many points as I can. So please make sure your screen's on. Please make sure you're participating. All right, I'm going to take this off and we're going to check our work. So it says, in this case, you would not replace the s, you would replace the t. So the new equation would be 36 equals 4s plus 4. You will learn to solve equations like this later in the course. Well, we just figured out how to do it because we just worked it together. So how could you use the graph to find the size of the pond you could build with 36 tiles? Well, couldn't we use it to just go all the way up to where 36 is? So 36 tiles, and then we could come down and see how many feet it is. Is it the same answer as what we got? Looking for a yes or no?
Yes.
Yeah. So basically what I did was I went to 36, and then I came down. So that's showing me that that is 8 feet. All right. So there's two ways that we could have done that. We could have solved it like we did, or we could have used the graph to find that that side length was 8. Which way is easier?
I'm guessing The way that you just done?
Yeah, that's kind of what I was thinking. Since most of us don't know how to solve for x, that's probably the easiest way right now. But we're going to get good at it. I kind of like to show y'all stuff ahead of time, so that way whenever you see it more often, it becomes easier to you. All right.
How do you make that?
I'm just pretty good, man. I don't know what happens. Okay, so we should have been able to answer question 4, question 5, and question 6. So out of all the pages we've gone through, we should have been able to answer 1, 2, 3, 4, 5, and 6. If you do not have those answered, you need to be answering those right now, okay? And I want us to think about how algebraic rules that model the same situation can have different forms. So how are we able to use 4s plus 4 and change it into other equations that still give us the same answer? How are we able to do that? What did we do?
I mean, with the last problem that we did?
Yeah, like how did we use 4s plus 4 and change that equation? Like how we broke it up and wrote all those different number sentences. They gave us the same answer. How are we able to do that?
Because we took the T for tiles and we made it 36 because that was the main number that they gave us. Then we did 4s minus 4, and 4 minus 4 is 0. And then 36 minus 4 is 32. After that, we had 1s. What's it 1s?
We had 4s and we made it 1s by doing what?
We divided, and then
Mm-hmm.
we divided 32 divided by 4, and then we got 8. And then with 8, we got 8 equals s, and then we had 8 feet.
Good job. All right. So also, we talked about in class that we could take that equation 4s plus 4, and it was also equal to 2 times 2s plus 2. What property did we talk about that allows us to be able to rewrite this equation like this so that it works? We talked about it was a property that allowed you to multiply 2 by everything inside of the parentheses. Started with a D. Good job. The distributive property. The distributive property. Great job. All right. And so when would we need to create and use an algebraic rule? Why would we need that? Why did we need to use it earlier? Think back on page 5. Faith?
Nothing, I was just holding up.
Oh, good shot, girl. All right. So didn't we need it to determine this question right here?
Yes, sir.
All right. And that question was saying, how many tiles would you need for a pool that had a side of 5? We needed the equation to be able to solve that. And we also needed the equation to solve for if we knew the number of tiles. So you basically need the equation if you only have the side length or you only have the number of what?
Tiles.
Tiles. Good. All right. So for the end of class, for conclusion to this, what we're going to do is we are going to complete more practice questions 3 through 7 in Agile Mind.